Hello viewers, welcome to my channel. I am Hasham. Last three videos I have explained you about the probability, what are the schools of thought or approaches to the study of probability, what are the different theorems, multiplication and addition theorems, what are the different types of probabilities and Bayes theorem. All the theory I have already explained in the last three videos. Hope my regular viewers have already watched those videos. If you have not watched, go to the playlist of my channel. Select the subject statistics for management. See the videos of probability. Be perfect about the concepts which are used in probability. Now I'm going to start the problems on probability. So before starting the problems, I expect that all my viewers have taken the printout of the problems which I have given in the link under my description. Always keep ready the problems. Without problems, you cannot understand any answer. So always my suggestion, keep a printout ready. Take the screenshot of the first four answers, first four problems answers, then I'll explain everything in detail. Now see the first problem. The first problem on probability. One ticket is drawn at random from a bag containing 50 tickets numbered 1 to 50. So a bag is there in which tickets are there. The tickets are totally 50 and every ticket has a number from 1 to 50. Find the probability that it is a multiple of 5 or 7. First question. Second question, it's a multiple of 3 or 4. So we are drawing one ticket and random. What is the probability that it is a multiple of 5 or multiple of 7? The total number of tickets are 50. So when one ticket is drawn, then totally 50 ways are there in which we can draw the tickets, and mutually exclusive, equally likely and totally exhaustive outcomes. Now one ticket is drawn out of 50. So the total number of outcomes are 50. Because we are drawing one ticket, any ticket may come. Either it may be 1 or 2 or 3 or 4, like that, up to 50 tickets are there. So there are totally 50 outcomes. Probability that it is a multiple of 5 or 7. So first of all, we denote A is the event that the ticket is a multiple of 5. Because we want what is the probability of 5 or 7. So A is the event that the ticket drawn is a multiple of 5. So what are the multiples of 5? Remember the table of 5. 5 ones are 5, 5 twos are 10, 5 threes are 15, like that up to 50. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. These are the multiples of 5 in 50 tickets. So totally how many tickets are there which are multiple of 5? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total 10 tickets are there which are multiples of 5, right? Then event B. B is the event that it is a multiple of 7. Multiple of 7. So how many tickets are there which are multiple of 7 out of 50? So remember the table. 7 ones are 7, 7 twos are 14, 7 threes are 21, 7 4 28, 7 5s are 35, 7 6 42, 7 7 49. So totally how many tickets are there which are multiple of 7? 1, 2, 3, 4, 5, 6, 7. So 7 tickets are there which are multiples of 7. And 10 tickets are there which are multiples of 5. So the probability of event A, the probability that it is a multiple of 5 is 10 divided by 50. The total number of outcomes are 50. Whereas favorable cases are 10. The probability formula, number of favorable cases divided by total number of outcomes. The number of favorable cases are 10. Total number of outcomes are 50. So 10 by 50 is the probability of A. Probability that the ticket is a multiple of 5. Similarly, P of B. Probability that it's a multiple of 7. So how many favorable cases are there? 7 are the favorable cases out of a total of 50. So 7 by 50. This is the probability of B. That is the probability that the ticket is a multiple of 7. Right? P of A we got, P of B we got. Now P of A and B. Find out any ticket which is multiple of both 5 as well as 7. Now compare these values. In these values, is there any common value? Yes, there is one ticket which is a multiple of 5 and also multiple of 7. Which is the ticket? 35, you can see. 35 is a multiple of 5 and 35 is a multiple of 7. So you can find one ticket which is a multiple of both 5 as well as 7. So P of A and B. Probability that it's a multiple of both. One ticket is there. So 1 by 50. 35 is common. So the events are not mutually exclusive. This A event and B event are not mutually exclusive because there is one ticket which is multiple of both. Mutually exclusive means when A happens, B will never happen. When B happens, A will never happen. No ticket is there which is multiple of both. Then we can say mutually exclusive. Here it is not mutually exclusive because one ticket is there which is a multiple of both. The events are not mutually exclusive. So addition theorem, P of A or B is equal to P of A plus P of B minus P of A and B. Already in the last theory video, I have explained you in theorems, addition theorems. In addition theorems, two theorems are there, mutually exclusive, not mutually exclusive. If the events A and B are mutually exclusive, then P of A or B is equal to P of A plus P of B. That's it. If it is not mutually exclusive, P of A or B is equal to P of A plus P of B minus P of A and B. So here P of A or B, P of A plus P of B minus P of A and B. P of A, how much is P of A? 10 by 50. P of B, 7 by 50. P of A and B, 1 by 50. So LCM, if we take 50, so 10 plus 7 minus 1, it is 16 by 50. So therefore the probability that it's a multiple of 5 or 7 is 16 by 50, or if you simplify, 8 by 25. So we can write either 16 by 50 or we can write 8 by 25, both are same. That's all. This is the probability that the ticket drawn is a multiple of either 5 or 7. Same way. It is asking you what is the probability. Second question. In the same second B bit, it is a multiple of 3 or 4. Probability that it is a multiple of 3 or 4. Here we have taken 5 or 7. Now we are taking 3 or 4. So A is the event that the ticket is a multiple of 3. Now how many tickets are there which are multiple of 3 up to 50? So remember the table. 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12, 3 5s are 15, 3 6s are 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48. After 48, 51 will come. But we have only 50 tickets. So 48 is the last. So how many tickets are there which are multiple of 3? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 cases are favorable. 16 tickets are there which are multiple of 3. Similarly, B is the event that the ticket is a multiple of 4. So remember the table. 4 1s are 4, 4 2s are 8, 4 3s are 12, 4 4s are 16. 20, 24, 28, 32, 36, 40, 44, 48. These are the tickets which are multiple of 4. How many tickets are there? 12 tickets are there. So 12 tickets are multiple of 4 and 16 tickets are multiple of 3. So we are given P of A is equal to 16 by 50. Total number of outcomes are 50. So 16 by 50 and P of B is equal to 12 by 50. Now we want to check whether any common tickets are there which are multiple of both 3 and 4. Is there any common value? Yes. 4 tickets are there which are multiple of 3 as well as 4. What are the tickets? 12. See, 12 is the multiple of 3 and 12 is the multiple of 4. 24 is the multiple of 3, 24 is the multiple of 4. Then 36 is the multiple of 3 and 36 is the multiple of 4. 48 is the multiple of 3 and 48 is the multiple of 4. So how many common tickets are there? So 4 tickets are common. So P of A and B, probability that it is a multiple of both. 4 tickets are there, 4 by 50. So common values are 12, 24, 36 and 48. The events are not mutually exclusive just like this, because we have common tickets which are multiple of 3 as well as 4. So it's not mutually exclusive. So again, according to addition theorem, P of A or B is equal to P of A plus P of B minus P of A and B. So here P of A is 16 by 50. P of B is 12 by 50 and P of A and B is 4 by 50. LCM, if you take 50, 16 plus 12 minus 4, you will get 24 by 50. Or if you simplify, 12 by 25. So finally, what is the probability that the ticket drawn is a multiple of 3 or 4 is 12 by 25. That's it. First problem I have explained in detail. So always whenever you watch the video, I suggest you keep a notebook, pen, calculator ready beside you, so that whatever I am explaining, note it down immediately. If you maintain notes, then only you can be able to remember for a long period of time. Otherwise, you'll forget it. Simply watching, listening the lecture, you'll forget it. You have to follow up. You have to write the notes. Next, second question. Problem number 2. There are 17 balls numbered from 1 to 17 in a bag. The total number of balls are 17. And every ball will have one number. 1, 2, 3, 4 like that. Totally 17 balls, 17 numbers. If a person selects one at random, what is the probability that the number printed on the ball will be an even number greater than 7? So we have to find out how many even numbers are there which are greater than 7 up to 17. The even numbers are 10. After 9, greater than 9 it is same. Greater than 9. So after 9, 10 is the even number. Then 10, 12, 14, 16. Totally 17 balls are there. We will not go beyond 17. So 10, 12, 14, 16. So 4 balls are there which are greater than 9 number. Which are greater than 9 and even number. So favorable cases are 4 out of a total of 17. So one ball out of 17 can be drawn in 17 ways. When only one ball is drawn, there are 17 mutually exclusive, equally likely and totally exhaustive outcomes. The total number of outcomes are 17. Probability that the number printed on the ball will be an even number greater than 9. Even number greater than 9. The favorable cases are 10, 12, 14, 16. 4 numbers are there. The required probability, number of favorable cases divided by total number of outcomes. Number of favorable cases are 4. Total number of outcomes are 17. So 4 by 17 is the required probability. That's all. Next, problem number 3. What is the probability that a leap year selected at random will contain 53 Sundays? And same question, what is the chance that a non-leap year contain 53 Sundays? First of all, a leap year. A leap year consists of 366 days every 4 years. After every 4th year, leap year will come. So in a leap year, totally 366 days are there. In February month, we will have 29 days in a leap year, right? So total number of days, 366. And non-leap year, we will have 365 days. That means February month will have 28 days in non-leap year. Now, probability that a leap year contains 53 Sundays. We have to find out what is the chance, what is the probability. So in a leap year, which consists of 360 days, 366 days, there are 52 complete weeks and 2 more days. Every week, one Sunday will be there, and week consists of 7 days. Week consists of 7 days. So how many weeks are there? 52 weeks. If you multiply 52 into 7, you will get 364 days. 52 into 7, 7 days in a week, 364 days. But leap year consists of 366 days. So 366 minus 364, you will get 2 extra days. So we can say that a leap year will consist of 52 complete weeks. In every week, one Sunday pakka sure will be there. So 52 weeks means 52 Sundays are sure. But we want to find out what is the probability of 53 Sundays. So 52 Sundays are sure. Now how come 53 Sundays will arise? Because 2 more extra days are there. 52 complete weeks plus 2 more extra days. So what may be the 2 more extra days? The following are the combination of those 2 extra days. The combination are Monday and Tuesday. It may happen. The extra 2 days may be Monday and Tuesday, or Tuesday and Wednesday, or Wednesday and Thursday, or Thursday and Friday, or Friday and Saturday, or Saturday and Sunday, or last one Sunday or Monday. So how many combinations do we have? 7 combinations we have. Out of these 7, any combination which will have Sunday is a favorable case. In the first combination, no Sunday, leave it. Second combination, no Sunday. Third combination, no Sunday. Fourth, no Sunday. Fifth, no Sunday. Sixth one, there is Sunday, Saturday and Sunday. And seventh one, there is Sunday and Monday. So out of the 7 possibilities, 2 possibilities are there where we have Sunday. These 2. The number of favorable cases are 2 out of a total of 7. So 2 by 7 is the probability that the leap year will consist of 53 Sundays. 52 definitely we are having. 52 weeks, 52 Sundays. Extra 2 days are there. In those extra 2 days, if Sunday happens, then we will have 53 Sundays. So those 2 days are Saturday and Sunday or Sunday and Monday. So in order that a leap year selected at random should contain 53 Sundays, one of the 2 over days must be Sunday. Since out of 7 possibilities, 2 are favorable to this event. See here, these 2 are favorable. This is favorable and this is favorable. Out of a total of 7. So the probability, hence the probability that a leap year consists of 53 Sundays is 2 by 7. That's it. Second question is, the second part of the problem is, what is the chance that a non-leap year will consist of 53 Sundays? Non-leap year will consist of 365 days. That means 52 complete weeks and 1 extra day. 52 into 7, you will get 364 days. But non-leap year will consist of 365 days. 365 days. So we can say 52 complete weeks plus 1 extra day. So probability that a non-leap year will contain 53 Sundays. So in a non-leap year which consists of 365 days, there are 52 complete weeks and 1 extra day. That 1 extra day may be Monday or Tuesday or Wednesday or Thursday or Friday or Saturday or Sunday. 1, 2, 3, 4, 5, 6, 7. So totally 7 possibilities are there. The extra 1 day. Out of those 7 possibilities, how many are favorable? Favorable is only one, that is Sunday. So how many times Sunday we are getting? Only once. Only once. The probability of 53 Sundays in a non-leap year is 1 by 7. Out of 7 possibilities, only 1 possibility of Sunday. So in order that a non-leap year selected at random should contain 53 Sundays, one of the extra day must be Sunday. The extra day must be Sunday. So since out of 7 possibilities, only 1 is favorable. Hence probability that a non-leap year consists of 53 Sundays is 1 by 7. You can see out of 7 possibility, only 1 possibility we have Sunday. So 1 by 7 is the probability that the non-leap year will consist of 53 Sundays. That's all. Now, fourth problem. Problem number 4. Suppose from a pack of 52 cards, playing cards, 1 card is drawn at random. What is the probability that it is a king or a queen? So a pack of playing cards totally will have 52 cards. So when 1 card is drawn at random, there are 52 mutually exclusive, equally likely and totally exhaustive outcomes. 52 total number of outcomes we have when one card is drawn. Our favorable case is the card drawn should be either king or queen. So you must know how many kings are there and how many queens are there in the pack of cards. Remember here, in a pack of 52 cards, there are 4 kings and 4 queens. And no card will be there which have both king and queen. Every card will be a different card. So when we get a king card, we will not get the queen card. When we get the queen card, we will not get the king card. Mutually exclusive. So total number of cards in the pack 52. One card is drawn at random. So there are 52 mutually exclusive, equally likely and totally exhaustive cases. Number of kings are 4 and number of queens are 4. A is equal to drawing a king, B is equal to drawing a queen. So probability of A, probability of drawing a king is 4 by 52. And P of B, probability of drawing a queen is 4 by 52. The events A and B are mutually exclusive because a card may have king or may have queen. No card will be there which will have both king and queen. Either king or queen, so mutually exclusive. When the events are mutually exclusive, then P of A or B is equal to P of A plus P of B. That's it. The sum of the individual probabilities. So P of A or B is equal to P of A plus P of B. 4 by 52 plus 4 by 52, 8 by 52. Or if we simplify, 2 4s are 8, 226 times. Or 2 by 13. So we can write as 8 by 52 or 4 by 26 or 2 by 13. Same. So therefore probability that the card drawn is either a king or a queen is 2 by 13. That's all. So in this first video on problems on probability, I have completed 4 problems. So this topic normally students will find it difficult. So my suggestion, if you want the perfect knowledge, if you want a good command, watch the video not once, twice, thrice, and always maintain notes what I'm explaining. Then only you can enjoy learning this topic of probability. So if you're satisfied with my lecture, give a like to the video. Share my channel in your groups, in your friend circle so that more students can watch the video and enhance the knowledge. Give your comments. Subscribe if you have not yet subscribed. And buy the super thanks which is given below the video. Inshallah, we'll continue the problems in the next video.